Alright, boys and girls, welcome back to the drive-thru. Before we get started, shout out to Tech Deck Club! Alright, we're here with a 7-1 remix. Because somehow the video got deleted. I have no idea why that happened, but we're going to redo it and it's going to be better than ever. Exponential functions, okay? These go along with geometric sequences. Let's start by taking a look at linear functions. What happens in linear functions? Okay, well, let's say we go to 10, 14, 18, 22, 26. Is this a linear growth? Yes, it is, because we are adding 4 every time. And we call that 4 our slope. Every time we go over 1, we add 4. What do we need to find the equation? Well, the equation for this is y equals mx plus b. So we need to find our b by putting a 0 in, work backwards, we get a 6. So 6 is our b. So this equation would be y equals 4x plus 6. Let's bring up our graphing calculator. 4x plus 6. Let's look at our table. Boom. You can see that table completely matches our table right here. I wish I could move it, but it's not letting me move it right now because that's how it works. Can you move it like this? Can you move it like that? Can I swipe it with my hand? I cannot. Oh well, you get the idea. Okay? Alright, so for exponential functions, the difference is you multiply to get from one term to another. So a lot of times these things grow really fast. Let's say we just started with 2, and then we went to 4, and then we went to 6, and then we went, oh gosh. Here we do, screwing up the videos again. We went from 2 to 4, and from 4 to 8, and from 8 to 16, and now what are we doing? We're multiplying by 2. Good grief. Multiplying by 2. Multiplying by 2. Well, in this case, this is our R. Same thing, we're going to need a B, so put in a 0, work backwards. 16 divided by 2 is 8, divided by 2 is 4, divided by 2 is 2, divided by 2 is 1. That is still our B. We're still going to refer to our y-intercept as B. So here's the important thing from this section. The formula for exponential functions is y equals b times r to the x. So this equation would be y equals 1 times 2 to the x power, or just y equals 2 to the x power. In this case, those are the same thing. Let's pop it in. Y equals, clear, 2. You're going to be using this to the power, which is a hat, 2 to the x. Let's look at the table. 1, 2, 4, 8, 16, 32, 64. As I said, this thing grows really fast. Just if you could double your money every day and you started out with $1, after a month, after 30 days, you would have, I think that's $1 billion. Just let the math resonate on that for a minute. If you could start out with $1 and double your money every day, after 30 days, you'd have $1 billion. All right, here we go. So, exponential growth would be y equals b times r to the x, where r is bigger than 1. Okay, so if you look back to that previous example, our R was 2, and that's why it got bigger fast. Exponential decay would be y equals b times r to the x, where r is less than 1. Okay, so let's take a look at one in our calculator. Let's go y equals 1,000 times 0.95 to the x. So I chose one that's just smaller than 0.95. Sorry, I chose one that's just smaller than 1. Y equals. Now you're going to have to be good at typing these into your calculator. 1,000 times, I just use parentheses, 0.95 to the x power. Let's look at our table and investigate it. No, not the graph. The table. Sorry, I got to wait for this thing to graph. You're not going to see it. It's off the screen because it starts at 1,000. Let's scroll back up. Well, let me show you how to do this. Let me go to my table settings, and we want to start the table at 0. Now let's go back to the table. That's oh, look. We started at 1,000, and then we lost 50, and then we lost 48.50, and then we probably lost like 46. And you can see it's going down, but it's going down at a smaller rate. But let's see how much we'd have just out of curiosity after 30 days. So let's start the table at 30. And after 30 days, we're down to 214 of whatever it is we started with. These are very important things to so many sciences. Economics, biology, chemistry. This is like one of my favorite chapters. All right, so now let's just take a look at some of these things in the graphing calculator. We already have, but we just looked at the tables because I wanted to wait to let you see the graph. So let's look at the graph. And we're going to zoom, I think on this particular one, I want to zoom zoom 0. Did that do anything? Okay. So you can see there's the 1,000 right there. This point is 0, 1,000. Now if I continue to zoom out, you'll see this is the first graph you've ever had that had an asymptote. Okay, an asymptote is a line, in this case the asymptote is the x-axis. It's a line that no matter how far we go, we will never reach it, but we will get infinitely closer to it. So here's another scaled out version. And this, you can't see that line, but it is hugging that value right there. Well, why is that? It has to do with the math. So let's say you have 10 yards to go in a football game. You're 10 yards from the goal line. Okay? And you call a play, and the defense has a penalty, and the offense gets half the distance to the goal line. So now there's 5. Okay, and then you call another play, the defense has another penalty, and now you get half the distance to the goal line. So now you have 2.5. God, I bet you guys wish you had a math teacher that could do math. So then you call another play, and let's say the defense has another penalty, half the distance to the goal line, 1.25. And you run another play, and the defense has another penalty, and now it's half the distance to the goal line, 0.6. I have no idea. I'm going to screw this up. 2.5. And you get the idea. Here's the thing. If the defense just makes a penalty on every single play, you'll never get a touchdown. You will never get to the end zone line or to the goal line. And I can show you that with the graphing calculator, but let's figure out what this equation was. Here, we're not dividing by 2, although we are dividing by 2, but you can't use division. So we're actually multiplying by a half. And then we multiply by a half. And then we multiply by a half. So our R is 1/2. What is our B? Put in a 0. Our B is actually 20 in this equation. So that makes our equation y equals 20 times 0.5, which is a half, to the x power. (20 times 0.5 to the x power. Go ahead and graph it. Alright, so now I got to zoom. I just want to go back to normal. Zoom 6. So there you go. There you have it. That's what our graph looks like. That doesn't tell us everything. Let me look at the table. As we... Let's go back to the table settings. Let's start at 0. So look, you can see that these things match up completely. And you can still see that the numbers make sense in the Y column. And now they're getting smaller. And this is how close we are to the end zone. And they're getting smaller and smaller. But now they're in scientific notation, but they still exist. You're never going to get an actual 0 in that column. Although now you're getting to the point where you are really close to 0. For example, that one right there is 0.0000000006. That's what, pull it back up, that's what I believe that one is. So after 35 penalties, they're on the 0.00000000000006 yard line. That's it for the video. I hope this helps. Tech Deck! Boom!